Welcome back. In chemistry, a lot of the time, we're basically playing detective. We're trying to identify these unknown substances. So imagine you've got some mystery white powder. How in the world do you figure out what it is? Well, one of the most awesome-looking tools in our kit is the flame test. And today, we are going to crack this case wide open.
So the core idea is actually pretty simple, but it is super powerful. When you heat up the ions of a metal, we call them cations, they give off a very specific color of light. Each and every metal produces its own unique signature color. It's basically a chemical fingerprint, a total giveaway to its identity.
So yeah, that's the big question for today, right? How can something as simple as a Bunsen burner flame act like an interrogation lamp, forcing a chemical to spill the beans and reveal its true identity? Let's dive in.
Okay, but just like any good detective, your technique is everything. If you contaminate the crime scene, you get false leads, and it is exactly the same in the lab. To get a result you can trust from a flame test, you have got to follow the procedure perfectly.
It really comes down to this essential three-step method. First, you clean. You take a nichrome water loop and dip it in concentrated hydrochloric acid. That's going to strip away any old gunk. Second, you purge it. Stick it in the flame until it stops producing any color at all. And finally, you test. Dip that clean loop into your sample and pop it in the flame.
Now here's a super crucial detail. We always use a roaring blue flame. So why? Well, think about it. That yellow safety flame you sometimes see, it's full of glowing bits of carbon that would totally overwhelm the subtle colors we're looking for. The blue flame, on the other hand, is almost invisible. It gives us the perfect black canvas for these chemical colors to just pop. Okay, now that our technique is down, let's meet the lineup of suspects. For your IGCSE exams, there are 6 key cations you absolutely have to be able to identify by their flame color. So let's check out each of their unique fingerprints. First up, we have lithium. When a lithium salt gets in that flame, boom, you get this beautiful deep red color. Now, for your exam, the key term you have to remember is crimson. That's the word that's going to get you the marks. And a quick pro tip here, lithium is seriously stubborn. If you don't clean your wire like your life depends on it after a lithium test, that crimson color will stick around and contaminate your next sample, and that'll lead you to a false positive. So clean, and clean again.
Next up, sodium. This is the usual suspect. This is the one you'll see all the time. It produces this incredibly bright, persistent yellow flame. It's so intense, actually, that it can act as a masking agent, and it'll easily hide other more delicate colors if you've got a mixture.
And here is a tip that every single chemist learns the hard way. Do not touch the wire with your fingers. Your sweat has sodium chloride in it, yep, table salt, and even the tiniest little trace will turn that flame bright yellow and ruin your experiment.
Okay, now let's look at potassium. This one is way more subtle. It gives off this really delicate lilac, kind of light purple flame. Unlike that in-your-face sodium flame, this one is pretty faint, and you really need a sharp eye to spot it.
And because that lilac color is just so faint, even the tiniest speck of sodium contamination will completely overpower it. That's why having a super clean wire is so important, and it's also why chemists will often dim the lights in the lab to get a really clear look at the potassium flame.
Let's move on to calcium. This one produces a kind of earthy orange-red flame. A really great way to remember this and tell it apart from lithium's crimson is to just think of the color of a classic clay brick. Brick red is the perfect way to describe it.
So, and this is super important for exams, you have to be precise. Just writing red isn't going to cut it, because both lithium and calcium could kind of be described that way. You need to use the specific term, orange red or brick red for calcium, to make sure you get those marks.
Our next cation on the list is barium, which gives us a very distinctive light green or apple green flame. And just a quick safety note, unlike the other metals we've looked at, barium compounds can be toxic, so they have to be handled with care in the lab.
And finally, we have copper too. Now, this is a transition metal, and it gives a truly fantastic and absolutely unmistakable blue-green flame. This dual-color look is completely unique among the ions you need to know, which makes it one of the easiest ones to identify. So the flame test is a fantastic first step. It's a great tool. But what happens when the case gets complicated? What if you've got a mixture of different ions, or a really tiny amount? Well, this is where our own eyes, our main tool, start to let us down.
So on the left, you can see the problem. Our vision is subjective. That really intense yellow from sodium can completely mask the faint lilac of potassium. But on the right, you see the solution. An instrument can give us objective data, and it can detect colors and amounts way beyond what the human eye can see.
And this is where we call in the big guns, the high-tech forensics team. Flame emission spectroscopy. It's the instrumental method that solves all the problems our eyes just can't handle.
So how does this work? Well, the light from the flame is passed through a spectroscope, which is kind of like a super high-tech prism. It splits the light into all its different wavelengths, creating this pattern of colored lines we call a line spectrum. And here's the cool part. Every element has a completely unique line spectrum. It's the ultimate chemical barcode.
And this is its superpower. If your sample is a mixture, the spectroscope doesn't get confused. It just shows the combined barcodes of every single element present. All we have to do is match the lines in our unknown sample to the lines of known elements, and we can identify every single ingredient with total certainty. Case closed.
All right, so we've covered the method, we've met the suspects, and we've seen the high-tech solution. Let's wrap up this case with a final checklist of all the key evidence you need to remember.
Here they are, all in one place. Let's do a rapid-fire review. You ready? Lithium, crimson. Sodium, intense yellow. Potassium, lilac. Calcium, orange-red. Barium, light green. And copper-2, blue-green. You've got to memorize this cable. It's absolutely essential for your exams.
So what's the big takeaway here? It's all about understanding that you need the right tool for the right job. The flame test is qualitative. It tells you what is there. It's simple, but it's subjective. Spectroscopy, on the other hand, is quantitative. It can tell you how much is there. It's objective, it's sensitive, and it is incredibly accurate. So, from the simple beauty of a colored flame to the precision of a line spectrum, it's all about knowing which tool to pull out of your detective kit. And hey, next time you see a fireworks display, you'll know exactly what you're looking at.